Okay. So this is how we create a series, and this is how we check not is not a number. Yeah.
So one more
Not.
thing. So like she told me that if there is thousands of data, so when you import that data, it will have some space, isn't it? Instead of having none.
Yeah, it will have
So
blank. It will have someone. So if the data, if we have data in string format here, suppose this
yeah.
is my string, so it will store in, it will be, so here if we try to store the value, for example string, then it is stored as none. Okay, so if you want to check none cases here.
But if you are fetching thousands of data, it will not store as none. It will store as a space, isn't it? If there is space on the data, like you told.
No, if you insert that in series, if you
Yeah.
insert that in series, it will
Yeah.
automatically, if your data, if your column is string,
Yeah.
then blank will be replaced by none.
Yeah.
Okay, and if your column is numerical value,
Yeah.
and if you store that in a series, then that will be
Yeah.
replaced by man.
Yeah. Okay.
So just to identify that nan is a character or a numeric value, we use
So
these one like equals nan and equals none and so on. So just to find out which value, which kind of value it is, or
so so if you want to equate, so for example, if you want to equate nan is equals to nan, not a number is equals to not a number, this will not give you the correct result. That's why I showed you, like if you equate not a number equals not equal number, will give you false. If you also equate not a number equals no equals none, this will again give you a false. So how will you check not a number? For that you use is not a number, and if you pass not a number here, then this will give you the correct output. Okay. For example, here here in dt we have 1, 2, and nan, not a number, right? In dt we stored
Uh,
1, 2, and
uh,
nan.
so what if you store 1, 2, and space? It will give nan or no?
Yeah, it will give. If you don't give anything, then it will not be, I think, anything. If you give blank, then it will give it will, if you have a space, then it will be stored as space.
Yeah, that's what I mean. It's like if you have number and if the data is space or they haven't filled anything yet, so it will be space. So
Yeah, then
how
we will.
will we figure it?
Yeah, then we will fill this value. I will come on that. Then we have a fill any function, so we can give that fill any function. I will come to your question later.
what does dt stand for?
This is just a start, Himal. I will come to your question. Like if you
Uh,
only have a plan, then what we will do, we will come to that part. Okay.
oh,
In the 15th row, what is dt?
DT is right now we created our DT variable, right? We store DT series, all series information. We store here DT in DT. Okay. So this will give you all your boolean value. Like in DT, your this is one is a number. That's why it says false. Two is also a number. It says false. So we are checking is an a is an and, yeah, in third row it is an and. So this gives you a boolean value, and again if you keep a bracket here, then this will give you your NaN cases. It will give you all NaN cases. For example, 2 here. Okay. So if you want to look for all except non-NaN cases, what we do is we do till layer. This will give you all your value except not NaN, not NaN. Okay, clear? Navjot,
Yes, so
is
little
making
bit.
sense? Yeah, if we try to practice, that will make more sense.
I did practice about the nan, but this one is little bit different.
Okay. So yeah, so this is NaN is to check whether the value is NaN in my data or not. And this tilde sign means So everything except nan. Okay, so this sign means so everything except this condition. This condition means what? This condition. So everything except this
Number.
condition. Okay, this
Except
tilde
number.
sign.
Show everything except number.
So everything except not a number. So
Not a
this
number.
checks, yeah. So this checks not a number. Everything except not a number. This may basically this symbol means not. You can say not, not condition, not condition. You can say. Okay. So let's say if our value is stored in a dictionary, let's say so Alex has an email ID alex@gmail.com. John second email ID gmail.com. Third one is Jeff. He has separate email and his email ID is jeff.com. Okay. So we can store this information also in series. So dt equals pt.series. So this is also a one-dimensional array where this is my index, Alex is my index, and this is my value. So here if we select dt, so this Alex is my index and this one is my value. Okay. So if we do dt dot index, this will give me all index like my Alex John. This will treat this as an index. So if we need to see what we have, what email address is for Alex, we can give here Alex and check his email address. Okay, let's say my data is in in tuple. You can also store that information here. So let's say my data is Alex comma Nick. So this is, if we have this two bracket, that means data is in tuple. Check comma Adam Andrew comma Jeff. If we store this information in pd dot series bracket data, can get this information this way. We can even define our series. Even inside series we can even define our list. For example, let's say Alex here. So let's give physics chemistry. So this will be my value and my index. Let's say if I give my index as Alex Andrew, this will be my index and this will be my value. So likewise, if my data is in, so this is my dictionary. Okay. So this is my dictionary. If I want to change the index name, for example. So this is my series, this is my dictionary, and if I want to change my index name, for example, index, I want to give Alex, suppose John, and again Sam, suppose, let's say. If we look at our data, so we will not have Jeff information here because we have not mentioned the index of Jeff. That's why we don't have Jeff information here. So here we have two concepts here. One is lock and one is iLock. Okay. So if my series, suppose I created a series. So I created a DT series. DT equals dt.series. Bracket I passed some ABC, and if we do dt dot iLock and pass here the index and dt dot lock. So this whatever we pass here should be a number, and whatever we pass in lock, this should be in string. Okay. So this dt is my data. If I do dt dot iLock bracket 1, it gives second value, because the first one is 0, second one is 1, and first Alex is 0, John is 1, Sam is 2. Okay. What we can even do is, if we use a lock, this needs to be a string. Okay. So this is my, this, if we pass here John, this will give me John at the value. So here whatever this we have passed value here, this is my index. Okay. So 1 is index. So whatever we pass in log will be my index. So here John is index. So in this data frame, what are my index? So data dot index, if we do, so index are your Alex, John, and Sam is your index. Okay, in series. So to fetch first row of index, you will do, so first one will be 0, second one will be 1, third one will be 2. So if you do iLock 1, this will again give you this value. If you do lock, then you need to pass here string. Okay, so iLock for number, and lock for string. So you can even do you can even pass 1 here. This will also give you the same result. Okay, so you can also pass, you can also
Can you
pass.
please just tell me about the iLog? Why we put iLog here?
So iLock is to fetch information. For example, if you want to look for John, so John is in first position, right? So that's why you give 1. So if you give 2, this will give you Sam. So for Sam you have nan. So it gives you nan information. So to fetch information, we use iLock and log.
So iLog is the like
I-
a kind of query that we enter to fetch the data
It's not a query. It's you can say a function. It's a
function.
method. It's a method. You can method or function, you can say, where you can only pass numerical value. Okay, here the 1 is numerical. Okay, so you can only pass numerical value. So the iLock fetch your row fetch information from a row, and it should be number. I love. So yeah. So in lock, if you use dot lock, that means that should be a string. Okay.
Okay.
So let's say you have a student data, and so 90 means your 90 means physics. Code for 90 is physics. Okay. Your 80 is, suppose code for 80 is chemistry, and 100, suppose for biology your code is 100. Okay. So here we see, like, even we give data bracket 1, it gives you the same output. So what's the use of using iloc? You can simply give data bracket 1 and it gives you the same result. So what's the use of using iloc, right? You might have this question.
Yeah.
So here, so in this case, suppose you cannot use 1 here. So throw you an error. Why this is throwing you an error? Because here your key is numerical. Okay. So here you need to use .iloc. iloc is not working. If you do iloc 0, oh, we need to store this in a dictionary, in a series first. So st equals pd dot series bracket student data. Okay. So now if you give st bracket 0, this will not work. You need to use iloc. Why we need to use iloc? Because your key is your number. Okay. Here your key was your string. That's why you were able to use data bracket 1. Okay. But here your key is number, so you need to use iloc here. Okay. To fetch this information. Okay, so tell me what's the difference of iloc and lock? Iman, this is important question. What's the difference between lock and iloc? Iman, are you
Yes,
there?
yes.
What's the difference between lock and iloc? So iloc. So have you understood this example?
Yeah.
Yes, I'm that one.
So iloc is used to fetch. Iloc and lock both are used to fetch information from a row, but iloc accepts only number, whereas lock accepts only string.
String.
Okay. So that's the main difference between lock and iloc. So how to add rows
So
to a cell?
what if all the data have string as well as number then? Suppose you have a string as well as number stored on it, then
Let's say for example here, let's give ABC, okay, and let's give this as xy xyb. Okay. Now if you fetch 0 1 2 3, so yeah, it will work, like both will work, Both will give you the same result, but what the difference is, in the ilog you cannot use string. For example, you cannot use abc here. If you are using abc string, you need to give log. You need to give log.
So if you have this one, if you need to find the chemistry, then we need to write different function then.
Then you use ilog.
ilog
And then 0 1. That's the second index.
So you have to find the string, then we have to write again the different function like a log and string.
Yeah. No, for even the ilog will accept your string. So the string is in fifth 0 1 2 3 third row. Okay, so you can give here 3, and this will give you the value for string. But whatever you pass here, this should be a this should be a number. If it is a number, if you pass number here, then you need to use ilog. If you pass a string here, then you need to use log. That's the only difference. So if you need to add rows to a series, if you want to, suppose your series is ed.series bracket 1, 2, 3, and if you need to add 1 4 here, so what you can do a log, let's say, and if you want to add something, some value, let's say 8, if you do s, then you can add that information to log operator. Okay, so here you can see add is being added. So
ilog is for string and log is for number.
No, ilog is for number and log is for string.
Yeah.
Okay. And two series. So if you want to append two series, let's say if you have two data dictionary, one and dict one, this is alex1, gmail1, gmail1. If you want to append these two dictionary, what we can do is we can suppose, let's say, all underscore dict equals dict dot append. We can use open bracket dict one. So first we need to store this in series. So let's say d1 is equals to ed dot series bracket dict two is 1 d1 d2. So if you look all dict, you can see so two series being appended. Okay. So even if your series have similar name, for example, this also belongs to A, this is also A, this is also A, then even you can so it's right now, but if you need to, you can specify the index name. If you specify the index name, then it will work. For example, if you so if this is my series, this is my second series, here my index name is same Kelly and Kelly. If I want to open this to index, Now I can append by same name. And if I want to look for information of Kelly, what I can do is dot log like it Kelly. Then it will give me all Kelly. So it's a small case. Give me all Kelly. Information of all Kelly. So this Kelly is my index. Okay. Javaria, do you have any question? Hello.
It's not here, I think.
And so this is how we append information in a series, how we add a row in a series, how we fetch information from a series through log and ilog. Okay. So now let's go to data frame. So data frame, like I said, it's a two-dimensional array. So if it's a conceptually a two-dimensional series, so it's like a row and column in an Excel sheet where we have row and column. There we use the data frame to store our information. So whatever two-dimensional information we have, we store all that in our data frame. So
So
if we
Kelly
have,
we use for nahi, disk.log we use for what?
so this dot log is used to fetch all string information.
String information. Oh yeah, log. I log.
Ilog.
Okay, that's
So okay, so here I will write down here. So log is the first, it should be a string. Okay, log should be a string and ilog should be a number. Okay.
So it fetch all the information related to Kelly.
Yeah.
Okay. So in the data frame now, what we doing this one?
So data frame accepts data in, if we have a two-dimensional array, then we store that information in data frame. It's like a row and column in Excel file.
Yeah.
Note that. Okay, so what we do is ed.data frame record 1 comma record 2 comma record 3. Let's get this index as 1 is for student 1 comma student 2 comma student 3. So this is how we get the information in our data frame. So one simple question would be in your interview is to create a data frame. Can be one question. How would you create a data frame? So in data frame, what happens is the information should be in dictionary. Okay. So here we see one information in dictionary. So we should have some key value pair. We should have some key value pair. So key will denote your column and your value will denote your row. So we should have that two information to store the information in data frame. Okay. So another way of storing the information in data frame is if you create a list of dictionary. So what this is called, this one is in our book is dictionary and this bracket is list. So this is a list of dictionary. If we have a list of dictionary, we can store this in a data frame. Okay. So my index will be same. So to create a data frame, we need to have key value pair. We need to know the key and its value. So my key will be a column and my value will be a row. And the student 1, student 2, student 3, here is my index. Okay. So again, to fetch my student 1 information, what I will do is, let's say if I store this information in df, to fetch student 1 information, I can do I will say bracket student 1. This will give me all information of Alex.
So, for example, in Excel, for example, as we the title is student, and here we write different names and all the information. So, if here we just enter the number like student, sequence wise student 10 by iLog. So, even though it gives the information.
Yeah, whatever you enter in your index, suppose if you enter 10 here and df is 10, so if you give 10 here, this will fetch your first row.
Okay.
Okay, so whatever you give the index 0, 1, 2, 10, that will fetch your that row. So this one is for, so right now what we want to do is we want to fetch the first column name.
Mhm.
Okay, so how you can fetch your first column name is, so I want first row. First row is my student 10. Okay, and my first column. So to fetch first row, first column, you need to give here first column name and the ME. So this will give you Alice. Okay, so if you want all your rows that belongs to name, what you will do is give here column. Here, this will give you all value of your
Name.
name. So if you don't need this student, you can do dot values. You only give your name. Okay, dot, if you do dot index, you only give your index. Okay. So if you do, so this is my df. So if I want all my names to be, if we do dt dot t, what this does, this transpose your value. This converts your row into column. Your index will be converted into column, and your column will be converted into index. If you do df dot tt means transpose. Okay. Now if you want to look all your name, then what you can do is df dot t. So let's store this in another df1. Okay. So now your df1 contains all transposed value. Okay. So if you do d1 dot log bracket and give your name here, just give all your name. Okay, because it has been transposed. It has been transposed now. This is your index now. Okay. You can also give here. I can also give here like student 10. If you give, it will show your post name, Alex, right? Like we can even give a comma here. We can even do in this way. Both are same. So to fetch two volumes, what we do? So I log. So if you want everything, but you want to fetch only your student 2 and student 3, what we can do, student 2 comma student 3, you can give here. This will only give you 2 and 3. So we need to give this in list.
Why did we put a hyphen and comma before student 2 and 3? Like before, we did not put the same. We just put like in the square bracket student 1 and 2. It gave the result as well. Like
So
why did
this,
we put before like the hyphen and the comma?
so so here dt dot log. So this first one is, this is row, and then this is column.
Hmm.
Okay. So in dot log, row is our index. Row dot column. Column. So if you have multiple columns, what we do is, so if you want to fetch all index, so we keep double dot here, and if you want to fetch multiple columns, for that we keep two columns in bracket list of student one comma student two. So we keep this way. This means all rows, and this means two columns. Okay, that's why we keep here. That's why we did this to fetch two columns. Okay, clear now? Okay. So if you need to drop one column, let's work on df, because df is the main table. So if you want to drop one column, you can simply do df dot drop bracket your name, suppose if you give me. So you cannot drop your column. Okay, because if you want to drop your column, you need to give access equals 1. So what does access equals 1 means? So by default your access is equals to 0, which means check. If you keep access equals 0 means check access equals 0 means check row wise. Okay, if your access is equals to 1 means check column wise. So column wise. Okay, so your name is in column, right? So we need to keep drop equals 1. So now we see our output. We see we don't have name column. Okay, but again,
0 means that's one I mean index, and as the index start from 0, so x is equal to 0. Why?
access. So this is another concept. This does not
Okay,
relate.
like the graph we prepare, y-axis, x-axis.
No. So 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 in data frame. So inside data frame, axis equals 0 means you are checking data row wise. Okay, if axis equals 1 means you are checking data column wise. Okay,
So what if x-axis is -1?
we don't have -1 axis. I don't know if there is -1 axis or not.
Might be hidden secret.
Okay, so but again if you see df here, you still have name. Okay, so what this has done is it has temporarily removed this field, but in fact this has not been deleted. So to make this a permanent delete, we need to give here in place equals true. If you do a in place equals true, then if you check df, this will permanently delete your column. Okay, if you don't give in place equals true, this will not permanently delete your column. Yeah, so in many code you will see in place equals to, so it has already been deleted. That's why it has already been deleted. So this is throwing us the error.
I'm a bit worried. How can I remember all these things?
You need to practice. That's why you need to practice. Okay. Let's create a df here. Df. So now if you see, you still have, but if you do in place equals true, this will delete your column permanently. So another way of deleting your column is simply you can do del df bracket if you want to delete class. Let's say class. Okay. Now if you choose the df, this one is there. Your class is gone. Okay. So likewise, if you need to add a new column in a data frame, and new columns in data frame, I should so let's say if I want to add a rank column, simply you can give rank and non. Suppose let's say if you give a non here, so you have one column added, your rank column. Okay. So now, yeah. So now we have one data set. We will import that data set through read underscore csv. Read dot if my file is csv file. So here, if we go inside csv, this is my csv file. So to read a csv file in pandas, what we do is read underscore csv. Also, if you do tabs shift tab, here you can see the signature of your read csv. Okay. So how would you write your parameter, like your separator is comma delimiter? If you can give a header, you can use all these skip rows, skip footer. So you will have these all these parameters which you can use here. The help, this is your help button. So it's shift plus tab. If you do, you will have this same. If you will have this information. Okay.
So
So
any column we can search for these.
no, you cannot. This is a function. That's why you were able to search.
Okay, first we need to assign df is equal to something like this, and then
So let's say if you see these, and if you do shift tab, so this is, you can have that information here. Okay.
which tab
So
did you press?
you need to do shift plus tab. Such I have to shift plus. I don't know in Mac, but it's in, this is in Windows.
Mhm.
So read underscore CSV. So for my data set, we have data in this inside data set slash admission underscore predict dot CSV. Okay. So this information, this file is loaded. So this file is loaded. Now if you want to see top 5 row, then df.head, if we do, this will give us top 5 rows. Okay. So another thing is we can even assign this, we can even add an index in our, while reading a csv file. If we do index equals 0, what this does, it looks for first column. So this first column is series number. Okay. So if we do df.head, so it's index underscore col column. So if we do here, if you see, so here if you see, so in the syntax is index underscore column. Okay. So here if you do equals 0, your first column will be your index. Okay. So if you do 1, then your second column will be your index. If you do 2, your third column will be your index. So if you want to only fetch your column, if you only want to fetch your column, so what you can do is df.columns columns. If you do, this will only give you column information. Okay, so let's say if you want to rename your column, let's say if you want to rename the SOP to statement of purpose, what you can do is, if you want to rename a column name, you want to rename, what you can do is df.rename bracket columns equals, and to pass here dictionary. So SOP, if you want to rename the SOP to, this is statement of purpose. Okay. And again, let's say if you want to rename your LOR to letter of recommendation, let's say. So here, if you say you did LOR, and but your LOR column is not changed. Okay, so why this is not changed? Because if you do df.columns here, you can see you have one extra space here. Okay, LOR, you can see one extra space. Okay, so how to remove this extra space? One way is to manually add space here and remove, but this way is not an efficient way, because we can, if there's a let's say 100 200 columns, and doing this manually will not help us. Okay, so what we can do is we can remove all the space from our header. So how to do is, we have a stripe function here. Stripe, what stripe does is, it removes all the space. Okay, so if we do df dot rename, and mapper will be equals to str.strip stripe. If we do, so we need to set our access to what, 0 or 1? 1, because we are changing the column information. So stripe, what does is, it cleans your all space. If there's any space there, the stripes cleans that space. So new equals, let's set this to new variable, and if we look at dot minus columns, if we do, here you don't see any space. Okay, so another way of removing space is, say, what we can do is, we can write a list comprehension. So I have discussed about list comprehension in our first class. So list comprehension starts with 2 square bracket. Okay, so I will convert my x to lower, and then I will write a stripe. Okay, x stripe for x in, let's say this is my dt. So x in dt dot lower, first I will convert this into lower, and then I will stripe. Yeah, so this is my name underscore columns, let's say. So then my df dot columns will be equals to the name dot column. And if I see my df dot columns, all is in lowercase and space has been removed. So now if we apply this to our df, so now this is in lowercase So let's convert this in lowercase LOR. This to small case. So if you do, this is being converted. Okay, so the strike function, what this does is it cleans all our space. If we have any space in columns or even in data, it will clean your space. So if you do access equals 0, that will clean all your columns. In your columns, if you have any space in your columns, if you do access equals 0, that will clean your all your that will strike all information from the column. Any question here?
It's okay, but a little bit confusing as well. I don't know. It's like too much.
Yes. Yeah, try to practice yourself and that will make sense once you do by yourself. Okay, let's stop till here today.
Yeah.
Okay.
Yeah.
So last week assignment I told you to do. I think we're not able to start that.
So, which assignment for the case you're talking about?
There was an assignment here in week 4. I have attended one assignment. I told yesterday that you need to do this assignment. Try to complete this by next week now. Okay. Any question, anything you want to ask to me?
I'll ask you like when we do.
Yeah.
Definitely.
Javadi hasn't spoken a single word today.
I don't know where is she. She didn't even answer my phone. Might be busy because their fasting is going on like kind of
Yeah.
festival. So they are a bit busy. Even after 5, I think they eat something, and sometimes visitor comes to each other home, something like that. So
Yeah, maybe. Okay. So we will meet again tomorrow, and tomorrow I will start with R. We will do a bit of R
So which
tomorrow.
time we have plans tomorrow? Same.
Same, yeah. Let's do the same.
Not possible on Sunday.
No, because I have managed my time accordingly. Okay, let's do it tomorrow.
Full day professional year class on Saturday. Like yeah, but it will from 9 to 5:30. So then again 5 to 8 here. I don't know. I would sleep. I know that.
So you will come at 5:30 tomorrow.
We'll try to finish come at 5. Because usually it's still 5. It finished by 5, but sometimes like students have some queries, and sometimes the lecturer he wants to announce something, so it just stretch up to 5:30 or so 5:15. That's okay. We'll ask him to.
Okay. Hmm. Okay, so yeah, that's it for today then. So tomorrow I will start with R and yeah. So I will start with R and I will start a bit of Excel next practice question. So as per our syllabus here, so as per our syllabus, we have covered this week 1 and week 2, and we are in week 3 in Excel. So in our statistics in R we have only covered week 1. So here 1, week 2, week 3, week 4 is remaining. This 1, 2, 3 topic, week 3 topics remaining. And in SQL we have covered 1, this 2 and 3 is remaining. And in Python we have covered 1 and 2 is almost we will cover this by next week. We will have 3 and 4 remaining. In Tableau, we have covered this third one almost. Today we completed using storage to build dashboard. So yeah, we still have much to cover. Yeah. So it will be, I think, we still have 6 more weeks. Not 6. So today is 6th week.
We started on, I think, 13th of March.
13th of March.
No. 13th.
This is our 6th week. I remember.
11th of March we started.
Okay. So tomorrow we'll start with R and Excel. I think Himal already went. Himal. Yeah. Okay. Okay. See you tomorrow, same time. Okay.
Yeah, thank you.
Bye. Thank you. Bye. Thank you.